Okay, so in this video, we discussed regularized logistic regression. And you'll see it's very similar to regularized linear regression. Python has different packages for logistic regression, but the theory is very similar. So our regularized cost function is our old cost function plus the same regularization term we saw in linear regression. And remember, with logistic regression, this h, this probability function, has this form with the exponential. It's the logistic function. So we can simply apply gradient descent as before with our new j. This means that we're going to update our theta j using the derivative. So we need to evaluate the derivative. There's a minor change to the derivative. This part is the same. Once again, just as in linear regression, we have the derivative of an additional quadratic factor, but the derivative with respect to theta j of theta j squared is simply 2 theta j, and the 2 cancels this 2. So we end up with this. Remember, this part here is what we had with logistic regression. Looks like linear regression, except you have the h theta here. And the added term is the lambda over m theta j. Now, we made the point in the last video that you could take this term and combine it with the initial term. So this gives the idea that the theta j update shrinks the theta j slightly and then makes the same update as previously without regularization. All right, so this looks very similar to linear regression. The difference is the h here. Now, in practice, you would not implement these equations, but you would go ahead and use a library function from SciPy or NumPy or scikit-learn. One way to do this is simply to optimize or minimize the cost function. So SciPy optimize has a general minimizer that will minimize any function. This minimizer takes several arguments. First, the function itself, which you would have to define as a function using a def statement. Then the initial values of your parameters. Then the arguments that appear in the function that are not the parameters you're trying to optimize. Then the optimization method. And then if in some cases, in some methods will require a gradient function, which would be the gradient of this cost function. And these are other options. This max limits the number of iterations that the algorithm will use to minimize. And disp equals true means that it displays all of the information about the optimization process. Right? So this result will be a minimized object. If you want the actual minimum values, you print result.x. This x is an attribute of the minimized object, which gives the minimum parameters. Now, result has other attributes also. You can look up minimize from SciPy optimize to see what other information you can get from result. Now, since minimize is a general purpose function and not specifically adapted to regression, your x must include also the constant features. So here it says x must contain an extra column of zeros. That should be an extra column of ones representing feature x0. So you'll have to add that to x. Unlike some of the particular regression implementations that will add the constant feature for you. Now, once you have your parameters theta, you can apply the same criterion for making decisions about data points, whether or not they belong to the class 1. Here you can apply h theta. If you set a threshold, you're simply going to have a threshold on theta transpose x. So you take your thetas, compute theta transpose x, and if it's above the threshold, you would admit x as type 1. If below the threshold, you'd admit x as type 0. So you can review the logistic regression video to see how that works. All right, now there is a specific implementation of logistic regression in scikit-learn. So here you have logistic regression. This command logistic regression sets up a model, and these are various parameters of the logistic regression model. You can look up what these means. Random state equals 0 just means how you initialize the logistic regression. There is some randomization involved in the algorithm. Solver, LBFGS, that's an optimization algorithm. Multiclass equals auto. So this is going to look at y and see if y has 2 classes or more than 2 classes. C we'll discuss in a minute. C corresponds to my lambda, but it's not true that C is equal to lambda. But C gives me my regularization. So once you have the model set up, then the model is trained on training data x, y. X is your training data, y is your corresponding labels. And then you can simply use clf.predict on other data to predict the classes for the logistic regression model. Now in this case, C is 1 over lambda. So that's how they implement it. So if C is big, that means lambda is small, and that means that you are not regularizing very much. If C is small, then lambda is big, the regularization has a large effect. Right? So C is small means lambda is large, more regularization. C is large, lambda is small, less regularization. So in this case, lambda would be 1/10. So this would be a slightly regularized model. Okay, that finishes our discussion of regularized logistic regression. We'll continue our discussion of logistic regression, talking about practical issues. The first practical issue we'll talk about actually still has to do with overfitting. When you have a model that's a polynomial model that takes powers of features, you want to have some way of deciding what powers of features to include. All right, so for more details on that, watch the next video. See you there.